Okay, we got to remember, what does this mean? So absolute value is given by two bars enclosing whatever it is that we're taking the absolute value of. So a couple things hopefully come to mind. Absolute value is something that always gives you a positive answer. So you might say this. But the thing we want to understand is that absolute value is also positive because it is giving you a distance. So a distance measurement from something is always positive. So when we get an answer for this, the absolute value of x equals 6, I can have an x of 6 because the absolute value of 6 just gives you back 6, but I can also have an x value of negative 6 because the absolute value of negative 6 is also equal to 6. Okay, so just a couple of ways to kind of look at this. So if I have that the absolute value of x is equal to 6, that's like saying that x minus 0 absolute value is 6. So it's giving me the distance away from, so if you look at this, my distance away from 0 is 6. So that's why I end up with a positive 6 and a negative 6. What I'm doing when I solve this is taking what's inside the absolute value, setting it equal to what was on the outside, but also taking what was on the inside and setting it equal to the negative, because of the fact that we said the absolute value of 6 equals 6, but the absolute value of negative 6 also equals 6. So I've got to take and set this equal to both the positive and the negative. If I look at this one, now when I'm giving another number on the inside, so x minus 5 equals 3, that's like saying the distance from 5 is 3. So if I start at 5 and I go 3 in the positive direction, I'm going to get 8. But if I start at 5 and go 3 in the other direction towards the negatives, I'm going to get an answer of 2. Again, what we're doing is taking what's on the inside and saying that that can be equal to what's on the outside. So x minus 5 equals 3, or taking what's on the inside, x minus 5, and setting it to the opposite of what's on the outside. And you can see when I solve it mathematically, I get the two numbers that we looked at graphically, 8 and 2. So what we're going to do each time we set up an absolute value problem to solve is I'm going to take what's on the inside, and I'm going to set what is on the inside equal to what's on the outside. But I'm going to set a second problem where I take what's on the inside of the absolute value and set it up to the opposite of what's on the outside. I'm going to solve both of those equations, and it's important to always double check when we're solving problems because we should be able to tell if we have the correct answer. And the important thing with absolute values is that in solving it, I can get some answers that are not true. Okay, so if I think about this one, I'm going to take what's on the inside, and I'm going to say x minus 3 equals 7, but I'm also going to take what's on the inside, x minus 3, and set it equal to the opposite, so negative 7. Then I'm going to solve these both, add 3 to get 11, and add 3 to get negative 4. So if I'm talking about that on a graph, what does that look like? Well, I'm saying from 3. If I'm looking on the graph and I'm starting at 3, this is saying that if I go 7 in either direction, well, if I go in the positive direction, wow, look at me. How about 10 over here? I'm going to get 10. And if I go in the other direction, I'm going to get negative 4. Okay, this is what I was talking about. It is important to check your solutions because when solving absolute values, you can get what is called an extraneous solution. You get that solution when you solve it, but it does not work when you plug it back into the original. So if I look at this, I'm going to have 4x plus 10 equals 6x, and I'm going to have 4x plus 10 equals 9 minus 6x. If I move the 4x, I'm going to have 10 equals 2x, so x equals 5. If I move it over here, I'm going to have 10 equals negative 10x, so x equals negative 1. So I would think that both of those solutions are correct because I just solved for them and got it. But when I plug back in, so if I look at this one, and I have 4 times 5 plus 10, and I want to say, is that equal to 6 times 5? Well, if I look on the inside of here, I'm going to have 20 plus 10, so the absolute value of 30 equals 30, and that's absolutely true. But if I look over here, and I have the absolute value of 4 times negative 1 plus 10 equals 6 times negative 1. Well, before I even look at this, I'm going to see that this is equal to negative 6. Well, an absolute value can never equal a negative number, so I know that this is an extraneous solution, and the only one I want is x equals 5. So again, the big things to remember with solving absolute values is to set up your two equations. One, where the inside equals exactly what we have on the outside. The other, where what you have on the inside is equal to the opposite of what you have. Solve them and check for extraneous solutions. And I'm going to get extraneous solutions whenever what I am equal to, what's on the outside, would end up being a negative by what I plug in.